So in this video, I'm going to talk about zeros and their multiplicities. So definition. If a polynomial function has a factor, which means x minus some number a, b, c, d, let's say h, to the p power, and the h is the zero. Sometimes they have a different name for it. Sometimes they call it the roots. Sometimes they call it x-intercept. H is the zero of multiplicity P. So here is some example. For example, I have fx equals to x squared times x plus 2 to the third, and then x squared minus 2 to the fifth. So here, a polynomial with three factors. This is the first factor, second factor, and the third factor. And each factor, which one is the s-intercept, or the zeros, or the roots? This means the same thing. So first step, let's find the roots, or let's find the zeros first. So the zero means we want to set the equation equals to 0. Then you will find three s-intercept, or three zeros, or three roots. The first one would be x equals to 0, so that gives us 0, 0. The second one would be -2, 0. The third one would be 3, 0. Oh, I forgot the power. So here are the zeros. And then what would be the multiplicity? So the multiplicity would be the power in here. So for example, in the first factor, the first x-intercept, the power was 2, right? So since the power is 2, so that means the multiplicity of this x-intercept is going to be 2. So usually I label that as m2. Similarly, second factor is x plus 2. That gives us the x-intercept -2. And then the power is 3, so that means the multiplicity is m3. Well, you may now find the pattern. The next one would be m5. Okay. And later we will discuss what do we need to know about this multiplicity. Now I want to have another example to find the multiplicity of each x-intercept. Second example, fx equals to 3x4 plus x to the third plus 3x squared. Now, this one, the first step is I will factor the common factor because I want them to look like multiple factor multiplied together. So common factor would be 3x squared. Then what's left is x squared plus 2 times x plus 1. And then I can factor the quadratic function, which is 3x squared, use AC method. I got x plus 1 squared. Or if we can see the perfect polynomial right away, that also work. That's how we factor it, or you can just go ahead and use the AC method. Okay, so next is let's identify how many x-intercept in here, how many zeros in here. So we will have one factor here. This is the second factor, right? From the first factor, we got the x-intercept is 0, 0. For the second one, we have an x-intercept -1 and 0 and 0. And then what will be the multiplicity, respectively? So the first one, the power is 2. So that means this is going to be m2. The second one, the power also 2, so that means this multiplicity also m2. Okay, now next, how does this multiplicity affect the graph? So remember when we talked about the long-run behavior, the graph, basically the end behavior will have two patterns. It's either similar to the quadratic function or similar to the cubic function. Here, the x-intercept behavior will be similar to these two. It's either similar to the quadratic function or similar to the cubic function. But this time, we are looking at the x-intercept of this graph. Okay, where's the x-intercept? So for the quadratic function, the x-intercept would be in here. For the cubic function, the x-intercept is here. Or this is the zero of the function, or sometimes they call it roots or x-intercept. Now, let's take a look. What happened? We don't look at the end behavior. We are working on the x-intercept behavior right now. It's also called the local behavior. Okay, so the x-intercept in here is bounce back. They touch the x-intercept. As you can see, go ahead, touch it and bounce back. So we call this behavior is bounce. And then for the cubic function, go to the x-intercept. This one, if it's bounce, would be look like this way, right? But it didn't bounce. It crossed it. It crossed the x-axis. So we call this is a cross behavior. It crossed the x-axis. It bounced the x-axis. Either way. Well, you may make a good guess. When do they bounce? When do they cross? Is when the multiplicity is even number, we bounce. So if the multiplicity is even, it will be similar to the quadratic function, they bounce. If the multiplicities are, should be an R, odd, then they cross. Now, let's go back to our graph in here. Look at those multiplicity. For the first one, this is M2, right? So that means this is going to be a bounce. And since this is M3, odd number, this is going to be a cross. And then M5, odd number, similar to the cubic function, the behavior will be a cross. M2, even number, this will be a bounce, similar to the quadratic function. M2, also another bounce. Okay, so now I'm going to show you what does that mean, bounce and cross. So if in a polynomial, oftentimes you will see a polynomial look like this time, up and down with multiple turning point all the time. So now let's take a look at each x-intercept. We have this x-intercept, this one, this one, this one, and this one. So this one, the graph is coming on the top, x-intercept, and then keep going down. So this is called cross, right? And this one also coming from the bottom, goes up, they also cross. This one is also cross. This one also a cross. Now look at the last one. They coming from the top, touch the x-intercept, bounce back. So this is a bounce. So with the x-intercept and bin behavior, we will be able to draw the graph of a polynomial. I am going to talk more about that in the next graph, in the next video.